carboxylic acids. What is the general formula of carboxylic acids? General formula RCOOH. In place of R, we can place hydrogen or any alkyl group. See the nomenclature. Nomenclature. In case of carboxylic acids, suffix. What is the suffix for carboxylic acids? In first year nomenclature we learned. What is the suffix for carboxylic acid? Suffix oic acid. Oic acid. Like methanoic acid, ethanoic acid, propanoic acid. Like that, oic acid is the suffix. And we use special name also, carboxylic acid, in special cases, right? Okay. Let us. In this, how many carbon atoms are present? How many carbons are present? One carbon is present. If one carbon atom is present, then what is the root word? Meth. Meth. So meth plus, is there any carbon-carbon double bond in this? No. So meth plus N plus oic acid, methanoic acid. Meth plus N plus oic acid, methanoic acid. Methanoic acid. I am mentioning IUPAC name within the brackets. Sorry, common name within the bracket. Methanoic acid also called as formic acid. Formic acid. Now keep star mark for the important common name. Okay, IUPAC name followed by common name, formic acid. Let us know about some points about this formic acid. Formic acid is present in, or methanoic acid is present in antistings. Antistings. That's why it is called as formic acid. Pharma means ant name, formica, ant name. It is present in the antistings. It is present in antistings. So it is prepared by distillation of ants. Which of the following is prepared by the distillation of ants? Right? Acetic acid. How many carbons are present in this? 2 carbons. One carbon in the functional group and another carbon. 2 carbons are there. So eth. Eth plus N plus oic acid. Ethanoic acid. Ethanoic acid. Ethanoic acid. Mention common name in the bracket. Tell me. Acetic acid. Acetic acid is the common name. Acetic acid is the common name. It is present in vinegar. Vinegar contains acetic acid. What is vinegar? 5 to 6% solution of acetic acid is called as vinegar. 5 to 6% acetic acid solution. Acetic acid solution is called as vinegar. This percentage slightly changes from book to book. You can follow this 5 to 6% or 4 to 6%. Okay, vinegar. Which is present in, which acid is present in vinegar? Acetic acid. Acetic acid. What is vinegar? 5 to 6% acetic acid solution is called as vinegar. Formic acid, acetic acid. Common names are very important. Right? Okay. Online students? Other students, please respond. Everyone. Yeah. Yeah. Next. Shall I clear this? Shall I clear this? See, I'll give you one code. This is already given in the nomenclature. Oh my such good apple. Oh my such good apple. Because see, we'll get questions on this code directly or indirectly. Okay. Let us start names related to this code. Take first letter O M S Z A. First, listen. How many COOH groups? How many CH2 groups are present in between these two? 0, 0, 0 and O. Both are resembling like alpha, beta, O and 0. Both are same only. So if 0 CH2 groups are present, that is called as oxalic acid. Common name I am giving to you, oxalic acid. Oxalic acid. How questions will come? Basic level questions. Basic level. Which of the following is a dicarboxylic acid? Contains 2 COOH groups. Dicarboxylic. This is a dicarboxylic. Previous one, monocarboxylic. Monocarboxylic. One COOH group is present. Dicarboxylic. Oxalic acid is the common name. Oxalic acid is the common name. It's IU because common names are important for them. That's why first I am giving common name. IUPAC name is ethane 1,2-dioic acid. Ethane 1,2-dioic acid. Ethane 1,2-dioic acid. Ethane 1,2-dioic acid. Right. Next, see what I am doing. I am inserting one CH2 group between these two. One CH2 group. COOH. COOH. In the middle I am writing CH2. CH2. Let's see, 0. Oh my such good apple increase. 0 CH2, 1 CH2, 2 CH2, like that, 3 CH2. Increase number of CH2 groups between COOH and COOH. O my means first 0. O means 0 CH2 groups. No CH2. Next 1 CH2. So letter is M. Malonic acid. Malic acid, no, malonic acid. Malonic acid. Difference is there. Malic acid and malonic acid, both are different. Malonic acid. Oh my such. M stands for malonic acid. Malonic acid. Can you give its name? IUPAC name? Anybody like this only? 1, 2, 3. Propane 1,3 dioic acid. 3 carbons are there. Propane at first and third COOH groups are present. So 1,3 dioic acid. Ethane 1,2-dioic acid. IUPAC name. Common names are important and IUPAC names also. Right. Propane 1,3 dioic acid. Dioic acid. Next, we have to insert two COOH groups. COOH. Insert 2 CH2 groups. One CH2, another CH2. See, you can write like this also. CH2 taken 2 times. Within the bracket, you can represent like this also. COOH, CH2 taken 2 times. This is also correct. Okay, both are correct. Within the bracket, we can write 2 times. Guess the name. Starting letter is S. Yes. Succinic acid. Oh my such. Succinic acid. Succinic acid. Common names are important. Succinic acid. Succinic acid is the common name. First I am giving the common names. Next IUPAC name. Give the numbering 1, 2, 3, 4. Butane 1, 4. 1, 4 dioic acid. butane 1,4-dioic acid. Oh my such. Next, glutaric acid. G stands for glutaric acid. COOH. CH2 I am writing directly 3. Glutaric acid. Next, you can write the name, IUPAC name. Adipic acid, COOH. How many CH2 groups will come? 4. Adipic acid. Adipic acid. Note down. Give the IUPAC names for this. What is this name? IUPAC name? Pentane 1,5-dioic acid. Total 5 carbons are there. Pentane 1,5-dioic acid. You can draw structure like this, and you can give the number. Hexane 1,6-dioic acid. Hexane 1,6-dioic acid. Note down. Lactic acid. Keep star mark for this. Keep important symbol for lactic acid. You tell me importance of lactic acid. Anybody? Yes, optically active. Very, very important. Which of the following is optically active carboxylic acid? See, this carbon is surrounded by 4 different groups. 1, 2, 3, 4. 1, 2, 3, 4. Middle carbon is a chiral carbon. This is a chiral carbon. Which of the following is optically active carboxylic acid? This is chiral center. The carbon which is surrounded by 4 different groups is called as chiral carbon or chiral center. This is optically active. Mention that point. Optically active carboxylic acid. You can give its name also. Can you give its name? Anybody? What is its name? Select the longest chain. No, name. 1, 2, 3. Like this. See, if you get any confusion, this is COOH, right? Keep C here and CH3 here, OH here and H. You can write H here. This is the longest chain, right? 1, 2, 3. Tell me what is its name? No idea. 2-hydroxypropanoic acid. 2-hydroxypropanoic acid. The optically active carboxylic acid is 2-hydroxypropanoic acid or lactic acid. Okay. Next, which of the following carboxylic acid contains plane of symmetry? Which of the following is a meso compound? See, in second year we use first year topics. We use first year nomenclature, we use first year general organic chemistry, we use first year isomerism. Okay, you can take directly applications or concepts from first year. Next, tartaric acid. Very easy to remember the structure. Tartaric acid. It contains plane of symmetry. What is plane of symmetry? An imaginary plane which divides the molecule into two equal halves. An imaginary plane which divides the molecule into 2 equal halves. Like this you can cut. Okay. If you cut like this, the upper portion and the lower portion both are same. appears the same, like watermelon. We can cut watermelon into 2 equal halves or not. This is a mesotartaric acid. Mesotartaric acid. Mesotartaric acid. Mesotartaric acid is optically active or inactive? Optically inactive. Why? Yes, if plane of symmetry is present, that is optically inactive. POS, plane of symmetry, optically inactive. So lactic acid is optically active. Mesotartaric acid is optically inactive due to internal compensation. Meso compounds are optically inactive due to internal compensation. Internal compensation means the optical activity of one carbon, one chiral center. For example, this yellow chiral center, optical activity is cancelled by the pink color chiral center. The optical activity of one chiral center is cancelled by another chiral center present within the same molecule. That is called internal compensation. Stereochemistry application. Okay. See, note down internal compensation. If you want, you can note down what is internal compensation. The optical activity of one chiral center is cancelled by other chiral center present in the same molecule. Other chiral center present in the same molecule. Important for first year also. Actually, this is first year topic only. Next. What is its name? What is its name? Propanoic acid. No doubt. Propanoic acid only. No? Once look at this, all of you. Look at this. Its name is acetic acid. Now what I am doing? Look at this. I am removing one hydrogen from acetic acid and adding methyl group. I am removing one hydrogen and adding methyl group. Now methyl acetic acid. Are you getting? First I took acetic acid. Look at this. CH3COOH is acetic acid. From acetic acid, what I am doing? I am removing one hydrogen and I am placing CH3. So methyl acetic acid. So propanoic acid common name is methyl acetic acid. For that I explained. Okay. Sorry. Propanoic acid. Write the common name also. Propanoic acid. This is the common name. Methyl acetic acid. Okay. Next. CH3CH2COOH. You can represent this structure like this. CH3CH2 two times COOH. Both are same. In middle, two CH2 groups are present. Right. Its name is butanoic acid. IUPAC's name is butanoic acid. 4 carbons are present. So butanoic acid. Common name is butyric acid. Present in butter. Butyric acid. Okay. Next important one. CH3, CH2. See, you tell me. Total how many carbons are present in this? You tell me. Just a concession. Sorry. One second. Now tell me. In the second, 5. Carboxylic acid with 5 carbons is generally called as valeric acid. Valeric acid. It is present in the valerian plant. Valeric acid. IUPAC name is easy only. Pentanoic acid. 5 carbons are there. 1 carbon here, 1 carbon here. 2 in the middle, 3. Total 5. Pentanoic acid. Pentanoic acid. Valeric acid. Know already about these names. Can you give its IUPAC name first? Give IUPAC name, then I will give the common name also. Try. In last chapter, we have seen similar compounds, but with the aldehyde CHO. That is, so it is crotanoic acid. Crotonaldehyde, crotanoic acid. So give the IUPAC name. 1, 2, 3, 4. Bute 2-ene or bute 2-ene oic acid or enoic acid. Bute 2-ene 1-oic acid. You can simply write like this also. 2-butenoic acid. This is also correct. 2-butenoic acid is the IUPAC name. Write common name within the bracket. See, very easy to identify common name and IUPAC name. In common names, there is no root word, bute, eth, meth, prop. Mostly, you cannot see the root words, bute, meth, eth, prop. Right? Crotanoic acid. Crotanoic acid. Which of the following is unsaturated carboxylic acid? Which of the following is unsaturated carboxylic acid? Unsaturated C acid. C acid is called carboxylic acid. Unsaturated carboxylic acid. Why? Why it is unsaturated? Double bond. Carbon-carbon double bond is present. Unsaturated compounds contain double bonds or triple bonds. Similarly, 1, 2, 3. First give IUPAC name. IUPAC name. At third position, 3-phenyl prop 2-ene 1-oic acid. You no need to mention 1-oic acid. You can write 2-ene oic acid. That is also correct. What is the IUPAC name for this? Sorry. Common name for this. Common name. That is cinnamaldehyde. This is cinnamic acid. Cinnamic acid. This is also unsaturated. Mention that unsaturated carboxylic acid. Unsaturated C acid. C acid stands for carboxylic acid. No, and just a second. Write this one also. After that, I will give you one more example. Caproic acid. Caproic acid. You tell me in this how many carbons are present? Okay. Now add this one also. One more example. Caproic acid. What is its IUPAC name? What is its IUPAC name? Its IUPAC name. How many carbons are present in this? So hexanoic acid. Caproic acid is the IUPAC name. Sorry, common name. Hexanoic acid is the IUPAC name. In IUPAC, root words will come. Very easy to identify IUPAC name. In IUPAC name, 99% meth, eth, but, prop, these root words will come. In the common name, root words do not come generally. Okay. Caproic acid. So, butyric acid, valeric acid, caproic acid. 4 carbons, 5 carbons, 6 carbons. Number of carbon atoms. Right. Start important organic aromatic carboxylic acids. Without having idea about the structure, you cannot do the questions like aromatic carboxylic acid acidic nature. First one, nomenclature, continuation of nomenclature only. Benzene carboxylic acid. Benzene carboxylic acid. Benzoic acid. Benzoic acid. But we commonly call this by its common name only. Benzoic acid. Benzoic acid. You can write another representation also. C6H5. C6H5 COOH. Note on this also. C6H5 COOH. Copy directly. Don't neglect the names. Don't neglect the names. Second one. First one in aromatic category. This is second one. First one is benzoic acid. Second one. See, if benzene contains methyl group, that is toluene. And benzoic acid. Mix the two. Toluic acid. Ortho toluic acid. Keep star mark for all these. Ortho-toluic acid. Ortho-toluic acid are also called as O-toluic acid. O-toluic. O stands for ortho. Or another name. Orthomethyl. O-methyl. O-methyl benzoic acid. Orthomethyl benzoic acid. Orthomethyl benzoic acid. You will get like this also. See. Another important representation. See, you will learn about everything. O CH3 C6H5 COOH. Simple representation. OCH3 C6H5COOH means orthomethyl benzoic acid. Like you have to identify. If you get a representation like this, you have to identify. Clear? Sometimes you won't get complete structure here. So in this case only you have to take care. How to identify that? What is its structure? Orthomethyl benzoic acid. Okay. Commonly called as common name where it is toluic acid. This is common. Toluic acid. Next. In acidic nature questions, having idea about the structures is very important. Without having idea about the structures, you cannot predict acidic nature. Now, can you write the names? M-methyl, metamethyl benzoic acid, P-methyl benzoic acid. M stands for meta. M-methyl. You can write directly metamethyl benzoic acid. Paramethyl benzoic acid. Without question on the signature, you cannot expect the weekend paper. If you get this structure, you have to match this structure like this. Okay. O NO2 C6H plus COOH means orthonitro benzoic acid. Online friends, are you listening? Hello, are you there? This is important. See, the last year weekend papers, they given question like this instead of the structure. Instead of structure, they are giving questions like this because if they give the structure, no space will be consumed, right? Actually, no, that is also one reason. Look at the paper, lacks and will compress space. That's why they give like this. What is its name? O nitro means nitro benzoic acid. P nitro benzoic acid. And meta nitro benzoic acid. For last year students, I will give you my question. Yes, we will discuss. New students, we will discuss SDPX again. If one ring contains two COOH groups, or when you know with the full COOH groups, in other positions, in the meta positions, and in para positions. In matrix matching type, questions are coming. If two COOH groups are present in adjacent positions, other positions, that is called as folic acid. Folic, how to pronounce this? Folic acid. Which is iron, folic acid. Isofolic acid. Second one is isofolic acid. Isofolic acid. This is terifolic acid. Terifolic acid. Folic acid, isofolic acid, and terifolic acid. All dicarboxylic acids only. All are dicarboxylic acids only. In which hydrogen bond is present? In which hydrogen bond is present? Folic acid. Because two COOH groups are present in other position. Which type of hydrogen bond is present? Intramolecular hydrogen bond is present. Terifolic acid, TEI. Terifolic. Isofolic or terifolic acid. All are dicarboxylic acids. Correct. You know this compound very well. You prepare this compound in phenol starter, I think. What is Aspirin. What is aspirin? Aspirin. Acetyl salicylic acid, commonly called as aspirin. This is a carboxylic acid. Shall I clear this? Online students. Next is what? Next, aspirin. Acetyl salicylic acid, commonly called as aspirin. You know, salicylic acid actually, I have to do salicylic acid also. First, I have to do salicylic acid, then I have to do this. This is salicylic acid. Salicylic acid. Note down first salicylic acid. After that, aspirin. Salicylic acid is IUPAC. Ortho position hydroxyl. Hydroxy. Ortho position hydroxyl. Ortho hydroxy benzoic acid. Benzoic acid. Salicylic acid. It is a common. In salicylic acid, if you remove hydrogen and if you place acetyl, that is called as aspirin. Analgesic, reduce body pains. Aspirin. Acetyl salicylic acid. Number of functional groups in aspirin. What are the functional groups? Ester and functional group present in aspirin. Ester. This is ester. This is ester and acid. Completed. Last three compounds: malic acid and fumaric acid. Malic acid and fumaric acid. For every chapter in secondary organic, nomenclature is important word. Nomenclature. All of you complete the names by today only. Okay. Malic acid, fumaric acid, Which of the following is sister? Dicarboxylic acid. Which of the following is a trans dicarboxylic acid? You tell me. One code I give you. You tell me. The code same is ending with M, means M. Same last with M. Starting name. Starting the word M last and starting. Both are matching. Same side. In malic acid, two COOH groups are present in the same side. Same M, like remember. Otherwise, you will get confused. In which two COOH groups are present in same side. In which two COOH groups are in opposite. So simple trick. Same M. Means two COOH groups are present in the same side. Sister. This is isomer. Malic acid is cis isomer. You know cis. What is cis? If two similar groups are present on the same side, that is cis isomer. Trans isomer, fumaric acid. Two COOH groups are present in opposite positions. Trans isomer. Specific nature of these two compounds is very important. Tomorrow we will discuss specific nature also. So due to this cis and trans, acidic nature will change. Cascade method means first stage students you can try cascade. You ask clear. Okay. Geometry. Of course, you can answer. Anybody? I taught in general and chemistry. And simple reason is there. Madhika, no idea. Okay, we do this. Which is the more acidic? Which is the more acidic? More acidic compound. Malic or female acid? Why malic acid is more acidic? Yeah. So what happens in these systems? Why it is? Yeah, that is the correct answer. Hydrogen bonding. Because of hydrogen bonding, the conjugate base is stabilized by hydrogen bonding. I explained to now clearly for new students also. Okay, this one. Right.